Let us now review what the serum sodium measurement, or concentration, means as it relates to total body sodium. As we already reviewed, total body sodium reflects extracellular volume, as determined by a patient's clinical scenario and physical exam. It cannot be measured by a number. The serum sodium lab measurement is not equal to total body sodium. As we covered in the previous module, total body sodium cannot be measured. Rather, it is determined by physical exam and can be described as euvolemia, or normal total body sodium, hypervolemia, or high total body sodium, and hypovolemia, for low total body sodium. The serum sodium measurement is a concentration measurement that looks at the ratio of total body sodium to free water. Therefore, disorders of water balance and homeostasis are reflected in changes in serum sodium measurement values, which is our focus on this module. We'll focus on the mechanisms leading to water imbalance in later modules. To best illustrate this, we will look at total body water and total body sodium as separate entities. As discussed prior, total body sodium can only be determined by examining the patient. It cannot be measured. If a patient is hypervolemic, like in kidney failure or heart failure with edema, we know that they have high total body sodium. If a patient is hypovolemic, as in someone with high volume losses with diarrhea or vomiting, they have a low total body sodium. The serum sodium measurement, or lab value, is a concentration of sodium per liter of water. Therefore, it tells us nothing about total body sodium. Normal values for serum sodium range between 135 and 142 milliequivalents per liter. Because serum sodium is a concentration representing a ratio of total body sodium to free water, a serum sodium measurement exceeding or deviating from the normal range represents a water disorder, not a salt disorder. Meaning, either there is too much or too little water, which will change the ratio of water to total body sodium. Let's discuss this relationship in more detail. Here you see two black dotted lines to represent our normal serum sodium and normal total body sodium. For our purposes, we'll use 140 milliequivalents per liter as our normal serum sodium lab value. For normal total body sodium, we can also use the term euvolemia. In a system with preserved water homeostasis mechanisms, meaning normal thirst response, adequate access to water, and normal release and response to ADH, the total body water should rise or fall proportionally with the total body sodium. This, in turn, maintains a normal serum sodium despite changes in total body sodium. These concepts are best illustrated by a series of simplified clinical examples for context. In example 1, we have a patient with heart failure and poor excretion of sodium and water by the kidneys, with exam findings of pulmonary and lower extremity edema with jugular venous distension. All of these are suggestive of a hypervolemic state and high total body sodium. A normal serum sodium of 140 milliequivalents per liter represents a normal concentration of sodium to water. Therefore, we observe a proportional rise in total body water, as depicted here. In example 2, we have a patient with kidney failure with more water intake than kidneys can excrete, with exam findings of hypertension and lower extremity edema, which is suggestive of high total body sodium. Remember, this is a hypervolemic state. Here, we also see the patient is hyponatremic with a serum sodium of 125 milliequivalents per liter, reflecting a dilute solution with an excess of water relative to total body sodium. In our next example, we have another patient with kidney failure, but this time they present with confusion from uremia and decreased water intake. They also have hypertension and lower extremity edema with a serum sodium of 150. The patient is hypervolemic based on clinical exam so we know that the total body sodium is high. A high serum sodium of 150 represents a concentrated solution, where there is less water than salt, also known as a free water deficit. In our next example, we have a patient with multiple days of diarrhea where they've been losing both sodium and water. They are hypotensive and tachycardic with a normal serum sodium concentration. This patient is hypovolemic, which is reflective of low total body sodium. Here, we see the total body water drops proportionally with the total body sodium to maintain a normal serum sodium concentration. In this example, we take a patient who has again been experiencing multiple days of diarrhea and sodium and water loss. But this time, they've been, quote-unquote, pushing the water dock, and they are hypotensive and tachycardic. By exam, they are hypovolemic, which is again reflective of a low total body sodium. In this instance, the patient is also hyponatremic with a serum sodium of 120 milliequivalents per liter. Here, we see a dilute solution where there is more water than salt, a water excess. In our final example, this patient has had several days of nausea and vomiting and has been unable to eat or drink. They are hypotensive, tachycardic, and have poor skin turgor. By exam, they are hypovolemic and have low total body sodium. Here we also see the serum sodium is high, suggesting a water deficit. Well, if you stuck around this long, I think it's time for a bonus round. Let's take a patient who has syndrome of inappropriate antidiuretic hormone, also known as SIADH, which we'll discuss in later modules. This patient has a normal blood pressure, moist mucous membranes, and no swelling. Based on exam, and by definition, this patient is euvolemic and therefore has a normal total body sodium. However, the serum sodium is low at 128 milliequivalents per liter. As you can see, this is a dilute solution with an excess of water relative to total body sodium. Well, that's our last case. I hope you've learned a little bit more about total body water and total body sodium and how they relate to each other.